Hello, I am Dheeraj Chawda from first year aeronautical department. Today I am going to present my poster. The first topic that we are going to discuss today is non-destructive testing of materials by using ultrasonic waves. What is the purpose of this method? The purpose of this method is to find out whether any flaw or defect exists in the material without damaging it by using ultrasonic waves. You can see here in this diagram that the beam of ultrasonic waves pass through the material in the presence of the flaw or defect. It is detected by the detectors. Now here is the CRO and the ultrasonic frequency generator. The ultrasonic frequency generator generates the beam of ultrasonic waves. The transmitting transducer then sends the beam of ultrasonic waves through the specimen. In the presence of the flaw in the specimen, the waves will reflect back and are picked up by receiver or receiving transducer, and they are further suitably amplified. This reflected beam is received by cathode ray oscillograph, or famously known as CRO. This beam produces a peak. The position of the second perk on the time base of the oscillograph will give the distance of the flow. This method is used in various industrial applications for detection of cracks or holes in the building. Moving on to our next topic, that is construction of solid state laser, ruby laser. Ruby laser was first invented in 1960 by Theodore Mainman, USA. Here is the 3D structure of ruby rod laser. There are four major parts in this ruby rod laser. First is the ruby rod itself. The ruby rod is a crystal of aluminum oxide Al2O3 in which it contains 0.5% of chromium Cr, and the color of the crystal is pink. It is a cylindrical rod of 4 cm in length and 0.5 cm in diameter. The second major part is the ends of the rod. Both these ends of the rod are grounded, polished such that they are exactly parallel and perpendicular to the axis. The one end of the rod is partially silvered for partial reflection, and the other end is completely silvered for complete reflection. The third major part is hexagonal xenon flash tube. This xenon flash tube provides pumping light to raise the chromium ions to the upper energy level. The fourth major part is the coolant. Due to thermal vibrations in the atom, the system produces heat. To reduce the thermal vibrations in the atom, the ruby rod is placed in the coolant, that is liquid nitrogen, in order to maintain the temperature of the system. Now, how this ruby laser exactly works? For that, we have our next topic, that is working of solid state laser, ruby laser. Here is the energy level diagram of ruby laser. Let us understand this in detail. First, in the normal state, the chromium ions is in the lower energy state, that is E1. When the ruby crystal is irradiated with the light of xenon flash, the chromium atoms are excited to the upper energy level, that is E3 excited state, where the light absorbent band is 5600 angstrom. This is transition number 1, optical pumping transition. Second, the excited ions in the excited state or the short-lived state E3 give up by collision part of their energy to the crystal lattice and decay to the metastable state E2. This transition is transition number 2, radiationless transition. The metastable state has a relatively longer lifetime of 10 raised to minus 3 seconds, greater than its usual lifetime, that is 10 raised to minus 8 seconds. Thus, the number of ions in the metastable state goes on increasing due to pumping, and the number of ions in the lower energy state goes on decreasing. This process of population inversion is established between E2 and E1. Here is a better diagram to understand population inversion. Third, due to the state of inverted population not being stable, the probability of transition number 3, spontaneous transition, becomes very high. When the ion passes spontaneously from metastable state to the ground state, a photon of wavelength 6943 angstrom is emitted. Now this photon travels through the ruby rod. This photon now starts to move in the parallel to the axis of the crystal, and it is reflected back and forth by the silver ends until it gives an excited atom. After the emission of the excited atom or the fresh atom, it returns back to the ground state. Fourth, the photon repeatedly moves along the crystal after being reflected from its end. Now, the stimulated radiation along the axis starts dominating due to multiple reflections. Due to multiple reflections, the photon beam parallel to the axis of the crystal grows in strength, and some of them burst out and serve as an output beam known as laser beam. A stage is reached where 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 the population inversion caused by one flash of the xenon tube is used up. The laser beam then ceases till the next flash of the xenon flash tube. This is transition number 4, laser transition, and the output wavelength is about 6943 angstrom. Here are some important details about ruby laser. The principal wavelength is 6943 angstrom, as you have known earlier. The intensity is about 10,000 watt, and the duration of ruby laser is 300 microseconds. This was all about my poster presentation. Thank you.